So in this video we will be talking about enol equivalents. So let's take this unsymmetrical carbonyl compound. If you add LDI in it, which is a base, then there will be formation of less substituted enol. Okay, there will be formation of less substituted enolate like this. Okay, so lithium enolate is less substituted enolate. If you want to form lithium enolate, you have to carry out this reaction at minus 78 degrees Celsius, and this is a less substituted enolate. But suppose if you want to make the more substituted enolate, then simply you just have to carry out like this. You have this carbonyl compound, you have to add trimethyl silyl iodide, and there will be reaction like this. This oxygen will take this silicon and this chlorine will leave. Then there will be formation of this double bond oxygen, silicon, trimethyl positive, and now we have a proton here. If you add triethylamine, then there will be removal of this proton instead of this proton, and the reason for that is because the transition state for removal of this proton carries positive charge, and that positive charge will be more stabilized on this secondary carbon rather than its primary carbon, and this is a very different concept. I will not be explaining it in much detail. Okay, so you can remove this proton and there will be formation of this more stable enolate like this, okay. So this is the more stable enolate, but the problem is that lithium enolate react with SN2 reacting reagents or SN2 reacting electrophiles, but this silicon enolates, or better you call it silyl enol ether, okay, silyl enol ether, these react with SN1 reacting reagent or SN1 reacting electrophiles, and also these also need Lewis acid for reacting with these SN1 reacting electrophiles. Okay, but there is no problem. If you want to carry out the reaction of this more substituted enolate with SN2 reacting electrophiles, then you can simply add here a organolithium compound or simply butyl lithium. Then there will be formation of lithium enolate like this, and now you can carry out the reaction with SN2 reacting electrophiles. In the same manner, you can convert this lithium enolate into silyl enol ethers by just reacting these with trimethyl silyl chloride again. Okay, now you don't need the base because the proton is already removed, so there will be formation of this enolate. Okay, now you can react it with SN1 reacting electrophiles. So these were the two important enol equivalents if you want to carry out the reactions with SN1 reacting or SN2 reacting electrophiles. Okay, so you just have to decide how to carry out the reactions, and again we have some more enol equivalents. One of these are that if you react this secondary amine with a carbonyl group, then there will be formation of an amine. Okay, I'm taking unsymmetrical ketone, okay, like this unsymmetrical ketone. If you react it with secondary amine, then there will be formation of an amine like this. And you have to remember that an amine formation takes place always on less substituted site. Here we have a hydrogen atom, it will come here and this bond will shift here, so there will be formation of less substituted enamine. Okay, so there will be formation of less substituted enamine. You can carry out the reactions of various SN2 reacting reagents like allyl halides or benzyl halides. Okay, allyl halides and benzyl halides and alpha halocarbonyl compound like this. alpha halocarbonyl compounds. So you can carry out these reactions well with this, but it does not react well with primary alkyl halides because there is always the problem of analkylation like this. Although there also occurs alkylation, but there is also some part of analkylation which we want to avoid. So for this you can use aginolate. Okay, in the same manner, if you react a carbonyl compound with primary amine, there will be formation of this compound. Okay, there will be formation of this compound. Now if you add LDA, so it will remove protons from here, less substituted site, and there will be formation of aginolate. So we have formation of aginolate like this. Okay, so now you can react it with very SN2 reacting reagents like primary alkyl halides or also these compounds. It will work well. So next we have aginolate, this and amine. So okay, these were the all. So you can carry out the reactions with well anything. You can also form these cations can be anything. Okay, you don't need to always use this LDA. You can also use sodium tertiary butoxide or sodium ethoxide, or even Grignard reagent you can use. Okay, so that will be magnesium enolate, so there is no problem. You can use any kind of proton removing base. Okay, so these were the enol equivalents you can use in organic synthesis. Thanks for watching.